Alright, this is video 8.3, and we're looking at solving two-step linear equations. So in 8.1 and 8.2 we looked at different types of one-step ones. These ones are going to be just a little bit more complicated. You've got to do one additional step. So remember, the aim of solving any linear equation is to isolate or get the variable alone. And we do that by undoing the operations that are being applied to the variable. So for example, if the variable was being multiplied by a number, we would get rid of that operation by undoing it. So the opposite of multiplying would be dividing, right? So we would divide by both sides, and that process would get the variable on its own. Okay, so problem is, or not the problem, but the reality is sometimes there are more than one operation being applied. So that means we're going to need to undo more than one operation, and that's going to take multiple steps. So the order that you undo these operations is related to when we do order of operations, but it's actually the reverse order of operations. So remember, order of operations, we do bed mass, so brackets, exponents, division and multiplication, and then addition and subtraction. And we're going to actually kind of flip that around so that we'll deal with addition and subtraction first, and then we deal with multiplication and division, like what we've done in the videos, the previous couple videos. So let's show you what that means. We've got an example here. 2x plus 7 is equal to 15. Okay, so excuse me. Remember the purpose again for solving is to try to get this x variable on its own. We want to get the x on its own, and in order to do that, we need to recognize what's happening to it. So we see that the x is being multiplied by 2, and there's also a 7 being added on the same side. So we think bed mass. Okay, bed mass says that usually you would do the multiplication part first and then the addition and subtraction, but remember we're going to do it backwards. So we're actually going to deal with this addition or subtraction, the plus 7, first. So if we are adding 7 to the variable, the way that we could get rid of that would be subtracting 7. 7 minus 7 is 0, so that cancels out. If we do it to one side, we better make sure we do it to the other side as well. Okay? So what I can write now would be 2x, that's what we had left on this side, is equal to 15 minus 7 is 8. And now we have an example just like what we were doing back in video 8.1 and what you've done in previous years. We see that x is being multiplied by 2, so we're going to divide by 2. Cancels off. If we divide one side by 2, we got to divide the other, and we end up with x is equal to 8 divided by 2, which is 4. Okay? Excuse me. Let's try one that's a little more complicated, simply because we're going to deal with fractions. Okay? So we have another one here. 2x plus 1 out of 10 is equal to 3 out of 5. Okay, so same thing, we look at what's happening to the x. Well, we've got a multiplication of 2, and we've got this addition of 1/10. So reverse order of operations means we're going to deal with this 1/10 first. If it's being added, to get rid of it, we're going to subtract. And we subtract 1/10 from that side, we've got to do it to the other side as well. Okay, and that cancels off, and we've got ourselves 2x is equal to 3/5 minus 1/10. So we'll have to go back to when we learned how to add or subtract fractions. Excuse me, we've got to remember that to add or subtract fractions, we're going to need a common denominator. Common denominator between 5 and 10 could be 10. So we've got to rewrite both fractions with that common denominator. So 3/5 becomes 6/10 minus 1/10. Okay, so I'll just move it up here. We've got 2x now is equal to 6/10 minus 1/10 is 5/10. Okay. Then we are going to recognize that x is now being multiplied by 2. To get it on its own, we're going to divide by 2. If we divide one side by 2, got to divide the other side by 2. 2's cancel. X is equal to 5 out of 10 divided by 2. Okay. So remember, when we divide fractions, that's the same as multiplying by the reciprocal. So 5/10, instead of writing divided by 2, we can write multiply by 1 over 2. Okay, multiply the numerators, multiply the denominators. We've got 5 over 20, which simplifies nicely to 1 over 4 is going to be your answer for what x is. Excuse me. Okay, and we'll do one last example here. Again, slightly more complicated when we're dealing with the fractions here, but same idea. N over 2 minus 3/4 is equal to 2 3/8. Okay, so when I see a mixed number like that, I immediately usually switch it to a improper fraction instead. So I do that. Switch 2 3/8 into 19 over 8. Okay, remember, you go the coefficient times the denominator, so 2 times 8 is 16, plus the numerator is 19 over 8. Okay, so I'm going to rewrite it now in that form. N over 2 minus 3/4 is equal to 19 over 8. Okay, the variable right now, n, is being divided by 2, and also there's a subtraction of 3/4. So again, reverse order of operations means we deal with the subtraction first. We're going to add 3/4 to each side. That cancels. So we add 3/4 over here. Okay, same as what we did before. We've got to find that common denominator. So common denominator between 8 and 4 is going to be 8. So we rewrite both of them in that form over 8. So 19 over 8 plus 6 over 8. Okay. Find some more room over here. N over 2 is equal to 19 over 8 plus 6 over 8. We add the numerators. 25 over 8. Okay, now remember, n was being divided by 2, so we're going to multiply both sides by 2. Okay, that's going to cancel there, so n is going to be equal to, multiplied by 2 here. Okay, so 25 times 2 is 50 over 8. Okay, and we can leave it like that, or we could put it back into mixed number form, and that's going to work out as 6 2/8 or 1/4. Okay, either of those answers would be fine. Okay, that's some two-step equations. I hope that's helpful.